Good afternoon, everyone. It's good to see you. I know our Zoom meetings have become our new best friend as we get to stay connected. For those of you whom I don't know, I'm Jim Rainbolt Bailey, and I have the pleasure of volunteering with our CoreNet North Texas chapter. My pleasure to welcome you today to our core conversation, which is a new benefit, a virtual benefit that we created for our sponsors, those folks who have generously invested in our work and our programs at CoreNet. And so during this time when it feels like some of us are as disconnected as we've ever been, we wanted this to be an opportunity for our sponsors to be able to connect with you and you connect with them as our thought leaders in our industry. Really excited about today, and I will tell you, I'm one of the most technologically challenged people there is. But even I'm excited about this today. We have Rick Freestat with Workspace Interiors by Office Depot, and he's going to talk to us about something that we're all hearing a lot about, but there's still a lot of questions. Rick, I can't think of a better setup than that to kick off with you, sir. So let's get you going. Good to have you today.
Thank you very much, Jim. I appreciate being invited to speak with everybody. My name is Rick Freestat. I'm the president of LED Lighting Consulting. I'm a manufacturer's representative for many lines of LED lighting and now UV disinfection lighting. I'm the factory rep to Workspace Interiors Office Depot and work with all their sales forces and their customers. And today, the topic was getting your workplace ready for return and keeping it safe, innovations in UV disinfection lighting. I'm going to try to play a video for you on the next slide. If for any reason it doesn't play, please let me know and we'll just move on from there. Sometimes I have problems with this. So we'll give it a try. So what this is one of the manufacturers we represent, Puro UV, is working with the New York City Metropolitan Transportation Authority, and they're using their units to disinfect the subways. And in conjunction with professors from the radiology department at Columbia University, they've proven that UVC disinfection lighting will kill coronavirus and many other things as well. So really, what is the goal of using UV and disinfection lighting? Number one, we want to protect against viruses, bacteria. We want to prevent spreading infections, future viruses or pandemics. So when coronavirus is over, we're ready for the next virus or pandemic. So we all know, how do we get infected? We know that COVID-19 spreads person to person, close contact within 6 feet of one another. It spreads in the air with large and small droplets from speaking, sneezing, coughing, or just breathing. It spreads on surfaces, contact with contaminated objects and surfaces, then touching your face or mouth. So how long will that last? Well, some of the technology and the data we get has been changing. It says on surfaces, it'll last up to 24 hours on cardboard and up to 3 days on plastic and stainless steel. And in the air, depending upon the size of the droplets, it can hang out in the air for as long as 3 hours. So we need ways to clean and disinfect both the air and also surfaces that we touch. So here's my technical slide. Try to hang in with me for just a minute. I'll try not to make this too boring. So UVGI, which means ultraviolet germicidal irradiation lighting, it's a disinfection method that uses shortwave ultraviolet light to kill or inactivate microorganisms, meaning pathogens or viruses or bacteria, by destroying nucleic acids and disrupting the DNA, leaving them unable to perform vital cellular functions. It basically neuters them. What it does is it messes with the RNA and DNA of viruses and they can't reproduce. So the technology is not new. It's been used for over 90 years to kill viruses and bacteria in disinfecting water, the air, or surfaces. So the shorter wavelength of the solar spectrum is more effective at neutralizing viruses and bacteria. When we talk about the solar spectrum, we're talking about what we get from the sun. So the UV spectrum ranges, and we count this in nanometers. The UV spectrum, which we can't see the light, is from 200 nanometers to 400. And that encompasses UVC energy that comes in, UVB, and UVA. And we don't receive UVC because that gets caught up in the ozone. But where we get our sunburns is from UVB and UVA. And then there's also some germicidal effects in the, they call it light blue, 405 nanometer spectrum. So it's widely known now that there's substantial germicidal and antibacterial effects from UVC, UVB, UVA, and near UV light spectrums. But what you need to know, if you want to kill a virus, which is coronavirus or COVID-19, you have to have UVC. And it works best between 254 and 265 nanometers. So all you really need to know is if you're going to kill a virus, you need UVC. But UVB, UVA, and light blue do have antibacterial effects and will kill bacteria, mold, and fungus. So that's the biggie, UVC to kill viruses. So what are the key benefits of using UV light for disinfection? Number one, it's environmentally friendly. There's no chemicals or residue. When it's done doing a cycle of cleaning, it eliminates all odors. There's no wait time after it's started or deployed. It kills rapidly and it starts within seconds. Microbial cells cannot develop a resistance to this technology. There's no way for it to build up resistance like we've had with antibiotics. And it's proven to kill SARS-CoV-2, COVID-19, along with other viruses, bacteria, mold, and fungi. So there's different types of bulbs, should we call them, light sources that generate UV light. There's low pressure mercury tubes, there's fluorescent UV tubes, there's a technology called pulsed xenon UV bulbs that flashes, there's now UV LED, and there's a new technology coming out called far UV LED, still being tested, not being used commercially. So we do get UV light from a lot of different light sources. So I wanted to say UV disinfection is going to work in conjunction with other cleaning and disinfection protocols. It's never going to eliminate good hand washing. It's not going to clean surfaces. It's not going to take a cheeseburger off a surface or dirt and grime or grease or blood. That all has to be done first. After you're done hand washing and cleaning, well, then we get into enhanced disinfection options. And what are your options? To use chemical fogging machines or chemical electrostatic misting machines or some type of UV disinfection lighting. It will do the same job as the chemical foggers or electrostatic misting machines. So why haven't you heard about UV lighting in the past? It's been deployed for at least 15 years commercially, especially in hospitals. That's where that's at least 500 hospitals use UV disinfection to disinfect their acute areas, their operating rooms, their bone marrow rooms, to make sure that in between any type of procedure, they're totally disinfecting that room. And the reason that it wasn't used commercially is these machines normally cost between $70,000 and $140,000 each. So that really cuts it out at being affordable for most commercial industrial types of customers. They're effective, they do a great job, but by the time you pay $100,000 for a machine and then $5,000 to $10,000 a year in maintenance to keep it working, and you have a full-time person running the cart around, it's really, a lot of people could not work with that technology, and that's why it's kept it out of the hands of community healthcare as well as commercial, industrial, other types of verticals. But they've used this successfully for a very long time. So when we talk about UV light systems, we were saying before that we need to clean surfaces and we need to clean the air. And not all things do both. So when we talk about surface disinfection, we're talking about mounting fixtures into the ceiling or walls, or taking mobile units that are meant to clean the surfaces and the air while it's running. Then they make, we'll call them light fixtures. They're not for making illumination, upper air disinfection units, where they go up high on the wall or hang from the ceiling, way above where they can reach anybody, and air will run through them, and UVC bulbs will disinfect the air in a particular room. Then they also make, we'll call them fixtures, that are put inside the ductwork of your air conditioning system. And it's usually mounted behind where the filters are. So the filter is going to trap your dirt and your particles and some of your virus and bacteria. And then you're going to have this UV light that's going to run behind that where the air is going to pass through it, and it's going to give some additional disinfection to the air going through there. And most recently, what we're seeing is a combination of LED light fixtures with a UV light disinfection component to it. So it can produce visible light and clean the air and even produce some surface disinfection at the same time. And I do believe that's what we're going to see more and more and more in the future, is these lights that will do disinfection as well. So we talk about surface disinfection. So surface disinfection lights, now again, these are not for illumination. These are purely for disinfecting viruses and bacteria on surfaces. They can be mounted in the ceiling, like this unit. They can be mounted on a wall like this unit. They can be put on tripods or casters and wheeled around. They can be run manually. Some of them have timers on them where you can schedule them for different days and different times, or even some of them can be integrated into a business management system so you have better control and reporting. And as we talked about these mobile units, you can just run them from room to room as needed. They have cords and plugs, or now there are battery operated push carts and autonomous robots coming out where it's kind of like a big Roomba, except that it's going to produce UVC light. It's going to determine if someone's in the room. It's going to go from space to base and work through large facilities. So they will disinfect all areas in the line of sight, as well as areas where light has reflected. UV light will reflect off reflective surfaces, off walls, off floors, and off windows. UV light won't go through windows. You have to have a transmissive polymer or some type of polymer to make it go through a surface. So it cleans the air and neutralizes odors while it's operating. UVC units can kill viruses and bacteria in minutes, depending upon what kind of intensity, what kind of energy is putting out of the system. There's a big difference. Some of these push carts can have 12 UVC bulbs in them, and some are miniaturized to the point where they have something that's 3 inches wide. And the UVA or 405 nanometer units can kill bacteria, but they need to run continuously to continue doing that. So this is for disinfecting surfaces. For upper air disinfection, this is where we're in a room, let's say a classroom, where we've got a certain ceiling height. We mount this on the wall up high, or we hang it from pendants from the ceiling, and it's going to possibly have a fan in it that's drawing air through it, and as that air goes through, they'll have UVC light in there that will neutralize the air, and it'll keep on pulling air through that and recirculating it in the room. So again, it typically uses UVC because we want to kill viruses. It will continually disinfect the recirculated upper air in a room. And to tell you what percentage it is, you have to determine what's the velocity in the room, what's the intensity of the bulb, and how many units are in a room, and we can determine that. Often, as I said, they have fans of them to draw air through the fixtures, but they have to be mounted high enough so that no light reflects off the walls or ceiling and back into the space. Because the good news about UVC is it will disable viruses. The bad news is you really can't take too much of it. It's a very strong energy, it's a very strong irradiation, and it can hurt your eyes or your skin. So anytime we're using UVC to kill viruses, you can't be in the room, and if you are in the room, such as these types of fixtures, they need to be up high and make sure that none of that light is coming down into the room. So they make these fixtures with baffles, so they throw the light out almost horizontally and up towards the ceiling, but not to the point where it's going to go back into the room. So you could have disinfection lighting pointing down on your surfaces and disinfecting your surfaces. And in conjunction with that, you could have upper air disinfection that's circulating, cleaning the air in a room. So for a very long time, your HVAC contractors have been putting UV bulbs or fixtures inside of the ductwork or the ventilation ductwork. When selected to produce appropriate irradiance levels, in duct systems can be effective for air disinfection, meaning that there's calculations to this depending upon how big an area, how much airflow is going through there. It tells you how much irradiance you're going to need to generate to actually have it be effective. So there are calculations by ASHRAE for that. So in-duct installations provide for facility-wide airborne pathogen reduction, and it will reduce contaminants settling on surfaces if you're killing those contaminants in the air. And installing UVC lamps and ductwork delivers around-the-clock disinfection. The units don't have seasonal dependence and they can operate year-round. They use a lot of energy. They're not, because they're UVC, they're not exposed to anybody in rooms because they're up in the ductwork, and they can be effective as well. So we're not saying you should use any one, depending upon the vertical, depending upon the type of building, depending upon what we're looking for. We might use combinations of this to get the purest, or should I say the most disinfected areas and surfaces. So here's where we're getting into some of the neat technology. We have combinations. This just looks like an everyday LED light you might see in the ceiling. And they come in 2x2, 2x4, 1x4s. But they're using LEDs that emit UV as well. So they will illuminate an area with visible light, and they'll also produce UV lighting for disinfection, not UVC. It's 405 nanometer or UVB or UVA, but it's not going to kill viruses with the light going down. But there's a lot of surfaces, bacteria. It will kill bacteria. So what are some of the bacteria that we fight with in certain areas? We fight with MRSA in hospitals. We fight with C. diff and C. auris. In areas where food is prepared, we fight with E. coli, Salmonella, Listeria. So these types of lights can be used even if you're working in a locker room or a fitness center or a gym where bacteria, mold, and fungi can grow. These lights can illuminate the space and also disinfect bacteria, mold, and fungi, all in one unit. So then we also have fixtures that are being made that are recessed, that look similar, that are made with illuminating LEDs, and also 405 nanometer LEDs like we talked about, that can illuminate the room and disinfect the room for the bacteria. And these can be on while you're in the room. Now, one of my manufacturers, Lumen Focus, is making a fixture, and it's similar to this, where it will illuminate a room. It will have UVC tubes behind the fixture where you can't see it. It's got fans to pull the air through the fixture, so the UVC is killing viruses in the air. And then it is also putting out 405 nanometer UV that's going to disinfect surfaces. So this one fixture is going to illuminate a room, kill viruses up high behind the fixture, and also disinfect the surfaces as well. And that's what we're seeing, these combination units that people are manufacturing. Now, there are people making UVC floodlights, high bays, for big areas, maybe for warehouses or for large assembly areas or manufacturing plants. We do have manufacturers that are making UV LEDs now for those bigger areas. So the neatest thing I just saw is that often in lighting, we're dealing with sensors to try to save energy or to save air conditioning, and being able to have it report back to a business automation system or an app that's watching all the time to make sure that we're not putting light where we don't need it because there's ambient light, and we're bringing levels up and down in specific spaces because people aren't in those spaces, or we're even raising and lowering temperature in those areas because people aren't in those spaces. Well, one of the manufacturers, I don't represent them, called Enlighted, is also now has added a workplace contact tracing application to its building IoT platform. They call it SAFE. And Enlighted offers a suite of data-driven, safer workplace solutions. It assists planners in preparing and executing physical distancing processes, enhanced sanitization, monitoring, occupancy limits, and now contact tracing. So SAFE provides digital contact history for employers who self-report testing positive for COVID-19 to help reduce the spread of the infection, keep healthy employees safe and productive, and eliminate tedious, expensive, and error-prone manual contact tracing processes for employees. So how it basically works is, one, the SAFE engine records the location of moving badges within a building. Number two, the engine then calculates distance between badges and time spent in proximity. Three is the space location analytics allow risk admins to visualize which spaces are the busiest, which are the riskiest, and where they're most overoccupied. And they give you powerful search and reporting features. So now you know if too many people are congregating in a room where there can't be social distancing, if too many people are in an area working together, or if you have people that have said that they've got COVID-19, they're introducing themselves to their coworkers, we have a way of tracking this. And they're using the same sensors that are deployed in millions and millions and millions of square space of existing buildings and using it for this as well. So I thought that was pretty interesting. So what are the applications for UV disinfection lighting? Well, obviously in healthcare, we know that it's been used for a very long time, but now it's becoming more affordable by the minute for walk-in clinics or dialysis centers or urgent care or maybe even therapy centers. Nursing homes, it's a great application for nursing homes, private schools. You can use UVC, and they've been using it for a long time to disinfect the core and coil units in air handlers, not inside the ductwork, but just keeping those coils clean. Obviously, it would help in food preparation areas where there are restaurants, in commercial offices, maybe in meeting rooms or break rooms or fitness centers or even public restrooms. In hospitality, we're seeing it, that's one of the lowest hanging fruit right now, is people are starting to use mobile units to disinfect the rooms, that within a 15-minute cycle, they can have a 99.9% disinfection in the furniture, the bedspread, the carpeting, the drapes, the top of the desks, the seats. So we're seeing a lot of national change bringing this on and advertising it actually. Obviously in fitness centers, it's a great thing to be able to clean fitness centers on a daily basis. Cruise ships, this type of technology will kill norovirus. So if it was deployed after every cruise and you totally did a deep clean, there wouldn't be norovirus on ships. Childcare centers, we've seen, I think you've seen that there's these mobile units that have wings on them that go up and down the aisles very quickly on planes. Retail stores are starting to deploy this for their cashiers. It's been used a lot, these mobile units in the emergency vehicles. So whether you've got a police car or an ambulance, whether you've got a bus, a transport vehicle to the airport and back, even for penitentiary transport vehicles, they're disinfecting these when they come in at night. It might be nice for your Uber vehicles as well. Any type of salon or where grooming is done, supermarkets at the cashiers or where they're preparing food. I tried to show you, the Mass Transit Authority in New York City is starting to use this, and I think there are 12 other mass transit authorities testing this technology now. This can be used to clean personal protection equipment as long as that equipment's in good shape, cleaning one side and then the other, in laboratories and pharmaceutical areas, in manufacturing and call centers. So there's so many applications for this technology, and I will tell you that the LED lighting industry has been dipping a little bit. The technology has been out there for 10 years. Some of the low-hanging fruit is gone. Obviously, the pandemic has hurt. There's not a lot of people worrying about saving energy right now as much as opening up their offices, finding a way to disinfect, and then keeping them disinfected. So you're going to see a lot of LED lighting manufacturers who already have all the fixture capabilities, the certifications, the raw materials, and the manufacturing facilities starting to implement UV in their fixtures as well, because they can do that by adding UVC tubes, or they can do that by adding UV LEDs, which still, they're still working on that to bring it down to the best possible nanometer range to kill viruses. But you're going to see a lot of the name brand manufacturers starting to come up with LED lighting fixtures that incorporate UVs in them as well. So in summary, we need to use a combination of hand washing, chemical cleaning, chemical disinfection, and ultraviolet light disinfection. All depends on the application, how quickly we need to disinfect a space, how often can we keep pumping chemicals into a space? Do we need to time things so every day when you walk in someplace it's totally disinfected without anybody touching it? So lights can be used to quickly disinfect any surface or space. Lights can be used to disinfect the air in any room. Lights can be used to disinfect the air as it passes through the air conditioning system. Lights can be used to provide illumination as well as disinfection. And lights can be used daily to disinfect with no chemicals, no residue, and no odors. And that's the end of my presentation. So I would like to thank Stephanie Subia from Office Depot Workspace Interiors for inviting me. And as their factory rep, anything that you might have heard about that you might be interested in, you can speak with Stephanie and we can engage a conversation from there. And I wanted to thank Jim very much for inviting me to speak today. Thank you.
Absolutely, my friend. Thank you. Wow. A lot of information, and I want to make sure that we have time for some questions. It was very telling to notice as you listed the different sectors where this technology could be applied. My heart sank just a little bit when I didn't see public schools and higher ed on there. And I think as we continue to, think about what the return to school is going to look like, how our public schools could benefit from this technology. One other note that I wanted just to bring out and see if you could address, there are a lot of commercials right now on TV for this little pocket-sized wand. And so if you happen to be going to the ATM or you happen to be going to the gas station, this wand shows where within just a matter of seconds, you're able to completely kill anything and everything that would be harmful to you with one pass of this wand. Legit or not legit?
Can't really say, but I will say there is an engineering technology to this. And the technology is, how big a space are we trying to disinfect? How far away from it are we disinfecting? How much ultraviolet energy is coming out of that unit? And how long would it have to stay there? So how can you say with a wand, keep it X amount of inches away, move it over X amount of space? Is it really enough energy to get the job done or not? So, I mean, Harry Potter has a wand, and I'm sure that works well also, but I can't say if some of those wands aren't viable. I would say if I was going to do that, I wouldn't be looking to buy it from Amazon. I would probably be looking for somebody who's been in the manufacturing space with HVAC for many years, who makes a commercial wand, because some do, to look to buy that from. And I will say to you, I didn't mean to leave that off my presentation, that particular space of schools and government, because yes, as a matter of fact, we're going to be rolling out a presentation of a whole system for getting kids back in the classroom and how to disinfect between classes and how do we keep the air safe. So yes, that is one of our priorities at this time as well.
We may have to have you back just for that. Would ask that any of our participants, if you would unmute yourself if you have a question, and throw that out there while we have Rick and his expertise available. Would love to hear from you.
Hi, this is Angie. Thank you for that. That is so interesting. And so one of the things that came up and you said at the end is that you can't just put one light in there and it's all done. It's a combination. So as we go about, I'm in corporate, how do you recommend we go about designing these spaces? Do you think are there experts that we can talk to? Is that you? Do you think that there will be other people trained in this that we can reach out to? What's your advice?
Yes, a lot of us from the lighting industry are actually moving into this industry as well. So I think there are UV lighting experts out there. And normally what we're going to do is we're going to look at your facility. We're going to talk about your facility and whether you can furnish a set of building plans so we can look at the floor plan and the ceiling plan. We can come up with a plan on which are the areas that are the highest touch areas, which are the areas where we would want to have it disinfected, you know, most critically, and what levels of disinfection can we live with, and which areas need spot disinfection. So yeah, I guess you would meet with somebody who has multiple lines of UV disinfection equipment and talk about how would we best do this for the least amount of cost but get you the protection that you need.
Excellent. Thank you, sir. Someone else?
Yes, I have a question. By the way, just adding to your prior comments, this is Julian Isarazu. I was watching recently a webinar. They were actually talking direct about HVAC and UV illumination for schools, and I think this is pretty interesting. But one of the questions I have on this regard is in terms of capital improvements, how much should be a retrofit with this type of lighting compared to a traditional LED light?
That's a great question about retrofitting, for sure.
And one of my manufacturers make retrofit units where you can literally take a light out and pop his in. But it's a lot more costly than just putting an LED fixture in. In some cases, you may be able to just put X amount of fixtures in a room and not replace all the lights to get the amount of UV disinfection that you need. It doesn't mean you have to change every fixture in a room. And like you were saying about systems that are used inside of air conditioning systems, what I'm seeing is that a lot of people are upping the MERV rating on their filters, and maybe up to MERV 13s. I was hearing about that on cruise ships the other day as a viable option, and increasing the amount of intensity from UV lights inside that. You know, but the problem that comes in with that, if I can just jump on that for a second, is, I mean, the best case scenario would be we get fresh air in the building, it runs through a room, it comes out, it goes straight out the building, we get fresh air again. Problem with that is that if you're not the temperature of the air coming from the outside, if you had to cool it all the time and you weren't recirculating air that was already cooled, your existing equipment more than likely wouldn't be able to handle it and function well. So what I'm saying is, you know, in a perfect world, sure, we get air from the outside, we bring it in, whatever happens to it on the inside of a building, and then we vent it back out again and we bring fresh air in again, but you're bringing hot air into the building, you're cooling it, you're letting it run through the building and putting it out and bringing more hot air in all the time. There's usually a damper and there's some type of percentage of fresh air and recirculated air in a building. You know, so that's some of the things that they're looking at also, is how much fresh air can I bring into my building with my existing equipment, because that makes a big difference as well.
Rick, thank you, sir. This has been amazing. And I feel like as this technology continues to evolve, there are going to be people that are going to want to be able to connect with you and with Stephanie and learn more about, you know, what's happening and how we're keeping workplace education, healthcare safe. Just want to thank you again. Great information. For those of you who have joined us today, this conversation we're calling Core Conversations are made available to all of our sponsors who have invested in the work of our Cornet chapter here in North Texas. So if you've sponsored anything at all, whether you're a chapter sponsor, an event sponsor, it could even be a whole flag sponsor at one of our golf tournaments. We're making this available to you because we feel like it's imperative to keep our membership connected, and especially with great thought leaders like Rick and Stephanie today as we're moving forward. So please check in and let me know if this is something that you would like to share with us as part of your core conversation. So again, thanks for joining us, Rick. We appreciate you and the expertise so much. Hope you all have a great, safe day. And until our next conversation, take good care. Bye-bye.
Thank you, everybody. Appreciate it.